Now let's take a very good question. It says that the base of the trapezoids are of the length 10 and 15, and we have to find the length of the line segment parallel to the basis which passes through the point of intersection of the diagonal and extended from one side to the other. So effectively it is asking about the length of this line segment which is passing through the center of the intersection of the diagonal. So let me assume it to be point P, O, and this point to be P, and point on BC to be Q, right? Now what I claim here is that PQ would be harmonic mean of AB and CD, right? So this is very important concept, so I'll prove it here, and the end result will be utilized to get the answer for this particular question, right? So let me generalize first. So let me assume that the sides are A and B respectively. Fine. Now PQ is parallel to AB and AB is all parallel to DC. So all these three lines are parallel. So we have a lot of pairs of similar triangles formed, right? Now let me invite you to observe triangle, say DOP. Look at this triangle DOP and triangle DBA. I say that these are similar triangles. The approach is simple because AB is parallel to PQ, so it will be parallel to PO also, right? So this angle will be equal to this. Angle D is common, so definitely these two triangles are similar. So from this I can say that PO upon AB would be equal to, say, PD upon AD, right? So this is the relation which we have got from the pair of these particular similar triangles. Now let me take triangle APO and triangle ADC. Here again these two triangles are similar because PO is parallel to DC, angle A, this much angle is common, so this angle, this entire angle will be equal to this, and this angle will be equal to this angle, because that is the AD and AC will respectively be the transversal. So these two triangles are also similar, and here again I can say that PO upon DC will be equal to AP upon AD, right? So if I mark this as equation 1 and this as equation 2, and if I add both these equations and substitute the value A and B respectively for AB and DC, then we get that PO upon A plus PO upon B, right? This will be equal to, now look at PD and AP. Because the denominator is same, that is AD only. Now PD plus AD, AP in fact, if you look at this, so AP is this much, PD is this much. So addition of them is nothing but AD. So this is effectively 1. Or I can say that PO is equal to AB upon A plus B, right? So PO will become common, 1 upon A plus 1 upon B. If you take it to the RHS, it will be AB upon A plus B. So this is one end results which I'll be using for the final claim which I have made, right? So one thing which we have done from this portion of the triangles, that is the triangle which involved the vertex P, the similar kind of things I have to do for the triangle which involved point Q. So let me take those pair of triangles as well. So here again, if I observe triangle QOC and triangle BAC, again these two triangles are similar with the same logic because the line PQ is parallel, or OQ is parallel to AB, right? And the one of the vertex C is common. So here again I can write that OQ upon AB should be equal to QC upon BC. Again, if I take triangle BOQ, which will be similar to triangle BAC, with the same logic that this angle will be equal to this much angle is equal to this, and angle B is common here, right? So all three angles are equal, so these pair of triangles will also be similar. So here again I can say that OQ upon, say, I think this should be BDC. So this will be BDC, right? So OQ upon DC will be equal to BQ upon BC. Now again look at this equation and this equation. Here BC is common and QC plus BQ. So QC plus BQ will make it BC. So if I add these two and substituting the value, so it will be OQ upon AB is A and OQ upon DC is B, and this should be equal to 1. So from this again we can write it as AB upon A plus B. Now we have got the next the second part of the PQ also and we know that PQ is a straight line. So PQ can be written as PO plus OQ, both of them equal to AB upon A plus B. So it will be equal to 2 times of AB upon A plus B. And that was my claim. So this is the answer, or in fact the end result, which we have to remember. That is the line passing through the diagonal, intersection of the diagonal and parallel to the basis will always be the harmonic mean of the value of the basis, right? So here for this specific question, the value of A is 10 and the value of B is 15. So the value PQ is 2 into 10 into 15 by 10 plus 15 will be 25. On solving, we'll be getting the answer to be 12. So 12 is the answer for this question.